Please stand by. This is W2NDG, the Overlook Mountain Amateur Radio Net Sunday Night Science and Technology Net, and we'll begin in approximately 30 seconds. I don't know if anybody's watching yet, but if you are, good evening. Good evening, everybody. This is Neil, W2NDG, from Highland, New York, beginning the Overlook Mountain Amateur Radio Club's Science and Technology Net. It's Sunday night at 8 p.m. YouTube is streaming, the radio is on, and we are all here. But let's pause and see if there's any priority traffic or emergency traffic. Please come now. Nothing heard. All right. So, once again, Neil, W2NDG from Highland, New York, and we are live on the Overlook Mountain Amateur Radio Club's repeater at 146.805 megahertz with a negative shift and a PL tone of 103.5 hertz. We are also streaming live on YouTube, and to find us, you just have to Google W2NDG Science and Technology. Either in Google or just look in YouTube for the channel W2NDG Science and Technology. The feed is also posted as a link on the Overlook Mountain Amateur Radio Club's Facebook page. All right. So we gather here every week to discuss science and technology, not necessarily ham radio related. Tonight, we're going to get into some science, both shallow and deep, which is somewhat radio related, but we're going to talk about energy and energy coming out of thin air or thick air, either or. But what we're going to discuss tonight is the subject of RF energy. I should have an echo effect there after that. And what is RF energy? For purposes of our discussion tonight, we're going to discuss the energy that is contained in radio waves. And that's probably the simplest way to put it. The simplest version of that a lot of people know would be something like a crystal radio. But there are more practical uses, things that you may observe in everyday life. But we're going to talk about a little bit of the theory, why we're able to extract energy from something like a radio wave. And we're going to talk about a little bit of the history of it, some early application, some more recent, interesting application, and some just everyday things that you may not realize use this same type of theory and technology. But first, I'm going to reach out and see if Jim is here. And Jim, K2BHM, is my partner in crime here on the Science and Technology Net, an engineer and a scholar. And we're glad to have Jim here. Couldn't do it without him. So, Jim, are you with us tonight?
Oh, yes, I am. K2BHM here. And very apropos that we picked up this topic because 60 Minutes did a very extensive expose on what is going on behind all of this tonight. Apparently, the CIA and the FBI have begun a campaign to eliminate birds, and they're replacing them with drones to observe us and monitor our every movement and so forth and so on. And we can verify that by the fact that all of these drone birds are sitting on top of the power lines to recharge their batteries. So, oh, it was fun tonight. I just loved it. Back to you, K2BHM.
And thank you all for participating in the amateur radio version of the Alex Jones Show tonight. There is a great picture I saw a couple of years ago that specified that COVID had been released so that we would all be home so that the government could change the batteries in the birds or upgrade their firmware or something to that effect. But yeah, that is one of my favorites. Jim, are you familiar with the movement or organization Birds Aren't Real?
That was the key point tonight.
So 60 Minutes did a story on Birds Aren't Real. I think it's a great movement because it really points out the absurdity of life. My hat's off to the guy who did it. My son introduced me to that. I hope Alec is listening tonight because that was a big deal. I enjoyed that. So, well, thanks for that, Jim. Gave me a smile. And anybody who's seen the picture I put up, either the thumbnail on YouTube or the picture on the OMARC Facebook page, for tonight's discussion, I put up a picture of me looking horrifyingly at a glowing light bulb in my hand. So, but tonight should be fun. And I think what I'm going to do is take check-ins early and just ask for some quick comments from everybody after they check in. So let's check in first, and then we'll take some quick comments of just what you think about this topic and what you might be looking to find out or where you think it should go. But it should be interesting. So to check into the OMARC Sunday Night Science and Technology Net, you give me your call sign, your name, and your location. And if you're watching on YouTube and you really want to check in, you can throw something into the chat and I'll mention that you're here. So please come now on the radio.
Control. Here is KB2 GGF back in Kerhonkson.
This is Kilo Bravo 2 Romeo Whiskey Bob. Oh, on his way to work. Just checking in. This is KD2 TVS Blue. This is WA2 RKN Jerry Hyde Park.
This is KD2 MNR checking in, checking out. I'll be listening though.
Okay, before we go on, before Matt, there was somebody who was too weak to make out. If you have more power or a better location, try it again. But yeah, before Matt, there was somebody in there. Oh, N2FCC, barely getting you. What's going on? You're usually better than that. All right, you're really hard to make out, Tom. But I know it's you. So if you get to a better radio, let me know. But yeah, you're really scratchy. All right, so we have Jim, K2BHM, Tom, N2FCC, which hoping Tom gets a little more power for us, Matt, KB2, GGF in Kerhonkson, Bob, KB2, RWW, just checking in. Bob, it was good to meet you today in person. Thanks for popping up there at the Hamfest. We have Lou, KD2 TVS in West Milford, Jerry, WA2RKN in Hyde Park, and Mike, KD2 MNR, just checking in. Thanks for checking in, Mike. And let's go around real quick, starting with Jim, and just seeing just a real quick comment on tonight's subject. What is there something it's specifically that you're curious about with it, or a comment you want to make on the technology itself? And then we'll get into the first part of it with Jim after that. So, Jim, quick overview or comments or something.
Thanks, Neil. Other than can birds recharge their batteries sitting on the power line, I was wondering we could explore what happens. You send a watt, 5 watts, 10 watts, 100 watts, 500 watts, 1,000 watts up the coax. What happens when it hits the antenna? And we'll explore that. Back to you, K2BHM.
Yes, and we're going to, there's a relationship between all of these physical properties, and that's what we're going to start with. We'll run through it, as quick as we can, but just to explain, where the energy actually comes from, which is kind of cool. And then, what you can do with it, what they have done with it, things like that. Matt, KB2GGF, your comments before we get going here.
I don't want to step on Tom. I think he was in before me.
I was going to slide him in at the end in case he got to a different radio.
Okay, just didn't want to be a line jumper. that gets you looked at, Yes, I'm very interested to hear what transpires today in the discussion, and more fire in the wire. It's electromagnetism, the invisible force that moves us. So, I'm real interested to hear what happens. So that's my stupid comment. And back to net, KB2 GGF.
All right, thanks, Matt. And next up would be Lou, KD2 TVS.
Thank you, Neil. KD2 TVS here. Didn't know you were going to be at the Hamfest today. I was actually there, probably left. I got there early, left around 10 o'clock. Wish I would have seen you. I've seen a couple of the guys from other clubs, but I think I heard that Steve was supposed to be there too, but I didn't stick around that long, I guess. I was there a couple of hours, picked up a few things, and headed home. Let me just reset. RF Energy. Boy, I mean, you guys a lot of you guys have been into ham radio way longer than I have. And my experience, I operated radios, but never really bothered looking into the technology behind it and how they actually work. I guess in school only taught us, hey, turn it on, dial in the frequency, and use the type of communications, VHF and HF, and don't remember much more than that back from school. So technically what I'm going to be is this is going to be like that, an older episode of Kung Fu, I guess. You guys are going to be the masters teaching me, and I'll be sitting here listening like a little grasshopper and picking up all this information that I should know, but only know just a little bit about. So Jim and Neil, just fill me up. Back to you, Neil. KD2 TVS.
Well, thanks, Lou. There's probably less with this topic expressly just with ham radio and more just with like radio in general. But it should be interesting. We're going to get a couple of household things around that we'll discuss as well. But it's neat. And we were there probably around the same time you were. I didn't run into it. Funny thing, Mike and I were at one of the booths, and there was a guy who kind of put his head towards us. He was like, "Oh, I know your voice. Yeah, you're Neil from the Sunday Night Science and Technology Net." So, yeah, I think I have 30 subscribers to the channel here. Anyway, cool. Tonight will be fun. Jerry, WA2RKN, pre-discussion comments.
Yeah, okay. That's what we went on high school. Pair of 811As. Hoorah. Let's not forget the mention of the inverse square law. Practicality. WA2RKN. Back to that.
Oh, yeah. We're not going to use a crystal radio on Mars. No, I get what you're saying. And interesting, one of the topics tonight is something a lot more recent as far as, RF energy theory, development, invention, we'll say. I was kind of surprised that it was as recent as it was. So anyway, cool. Tom, into FCC. Let's see if you're readable.
To FCC. Hopefully I'm readable now.
Oh, yeah. Possibly the most readable here. Loud and clear.
I was outside on the HT, and I could hear the repeater well, but don't get it too well. But now I'm inside on the big antenna. RF, the crystal radio always fascinated me. Something that has not powering itself is getting power from the ether. And imagine if you were someplace, maybe near a TV station that puts out a whole bunch of power. There's got to be a lot of energy in the air. And with low power stuff, you could probably power whatever device you have just from the RF floating around. And there's got to be a lot. Think of all the different RF devices that there are. TV radio and two-way radio and ham radio and stuff. So there's a lot of RF out there. So there's a lot of potential energy. And to FCC, back to that.
It's interesting. We used to joke around years ago, before there were cell towers, everywhere and everything. New Jersey was just a real hotbed of microwave links and communication. And we used to joke that, when you drove down the turnpike, if you, hung a hot dog on a fork out your window, that it would eventually cook before you got out of New Jersey. But yes, there is so much ambient RF radiation out there. And that's one of the topics tonight. We'll talk about that. Somebody who thought along those same lines that you do. And is there something that can be done with it? But crystal radios have always fascinated me as well. And we'll talk about that a little bit. So, all right. Do we have any check-ins before we dive in here? Nope, just the repeater. Repeater manufactured by the Last Word Amateur Radio Corporation, because it always has to have the last word. All right. I'm going to throw this up to Jim. And basically, the first part is Jim is going to be discussing the relationship between radio waves and electricity, and why we say there's energy in radio waves, and why radio waves come from energy. And there's a little more to it than that, but I'll let him expand on it a little bit. So, Jim, let's hear about the basics.
Thanks, Neil. Well, let me start off with a little anecdote from my childhood. I lived up in the Albany area, and there was a radio station by the call sign of WPTR. Rock was starting to become popular, and they had 50 kilowatts. And it was AM 1540 WPTR, and basically basically at the time, to put the numbers in perspective, if you were putting out 1 watt of RF carrier, CW, and you impressed on that a half a watt of audio, you were 100% modulation. If you went more than that, your carrier wave would be expanded more than 100% and down more than 0%, and it would cut you off, and it would go into spurious radiation and whatever. So it was not allowed by the SAC. Typically, you would go like 90-95% modulation. WPTR went 110 with 50 kilowatts. You could take a speaker, 8-inch woofer, ground one side to a water pipe, and take the other side and put it up to like 10 feet of wire, and you could pick up WPTR no problem at all, loud and clear. No radio, no nothing. So let's start from that, and then we'll digress. Let me drop it. WNBC. Anyhow, so that was the extreme. But basically, what I'm looking to explore tonight is you've got a radio, and you're putting out a watt, 2 watts, 5 watts, 10 watts, 50 watts, 100 watts, a kilowatt, 2 kilowatts BEP, whatever, into the piece of coax, and it goes up to the antenna. And what happens when it hits the antenna? What magic goes on after that? Because we all know that radio waves are black magic and witchcraft. So what happens when the current hits the elements? Hey, drop. So anyhow, when the power is going up the coax line, there is current going up the center conductor and back the coax shield. So the current going up the coax center conductor generates circular magnetic fields around the coax, which is contained what's inside the shielding. So it doesn't do much good. There's an electric field there, field potential between the center and the coax shield, but it's contained. And so all of that is kind of like uninteresting. Once it hits the antenna, that's where things happen. So let's start to think about the basic dipole. That's a good generic thing. So let's start with that. Let me drop. Okay, so you got a dipole. You're hitting it with a voltage at the center, and you've got an element heading out to the left a certain dimension, and heading out to the right a certain dimension. So right at that point, the center feed, where the coax feeds in, the voltage at that point is at a minimum because you've got the current at a maximum. The current is at a maximum at the center point and winds off at a minimum at the extremities because there's nothing out there to deal with it. So basically the current starts at a maximum at the center point and degrades to a minimum, and the voltage starts as a minimum at the center point and progresses to a maximum at the endpoints. And this generates both magnetic field, an E field, and a B field. And typically, correspondence-wise, the E field, the electric field, is in a vertical plane, and the B field or the magnetic field is in a horizontal plane. For a dipole in this particular orientation, and it propagates from there. And let me drop a second and see if there's any questions or comments at this point.
I have a quick one.
Okay, go ahead.
I wanted to mention something I was reminded of and was talking about today. And I wish, this is something maybe, Jim, you and I could work on, and maybe even with this gentleman's assistance. But he doesn't do the presentation anymore. His health has been failing him. But I had a guy come in for the club I used to be in Long Island who did a demonstration where he talked about the basic dipole antenna and the theory of it and how it, worked with ambient energy, basically, like we're talking. And he had this jig that he started with a basic dipole antenna. And he was receiving on it and powering an array of LED lights with it. And as the night went on, he would expand it a little bit. He made it resonant at a certain frequency. Then he added reflecting elements. Then he added directing elements. And then by the time the night was done, he had, I think, like a 10 or 12 element Yagi that he had built using, like I said, this step-by-step jig that he had. And as he went through each step of this and keyed up a radio with another antenna pointing at it, the lights got brighter each time. It was just really interesting. And if I can find a video of him doing it, I will. But if not, maybe that's something that we can come up with. I just thought I'd mention that.
Yeah, that is a good point. Because the basic dipole is bidirectional. The radiation patterns will head out. Let's say if your elements are facing north-south, your radiation patterns will be east-west. And coincidentally, your E fields will be east-west, vertically polarized, and your B fields, the magnetic fields, will be facing east-west, horizontally polarized. And basically, that's where we come up with the polarizations. And primarily, the magnetic fields will be the ones that will induce currents in the antenna on the receiving side. So that's why we need to be horizontally polarized transmit-wise and horizontally polarized receive-wise. So anyhow, so it's back to you, Neil. Any comments? K2BHN.
W2NDG on the Overlook Mountain Amateur Radio Club's Sunday Night Science and Technology Net. No, not yet. Just the idea of how it works, where, on one side, obviously, we can pump electrical energy into the air with our equipment and create radio waves. And then on the other end of it, we're looking at pulling it back out with an antenna and turning it back into power, electricity, wattage, as you're, And then there's obviously a lot more sophistication to it, but that's, as simple as it can be. But that relationship between electromagnetism, electricity, and magnetic fields is what gives us electrical generation and all sorts of interesting things. So I think, and see if you agree or disagree, when they were looking at electricity and how to generate it and how to manipulate it, that radio waves were kind of a byproduct.
Yeah, definitely. And Nikola Tesla thought that he could generate his Tesla coils and transmit energy through the airwaves to basically eliminate, in our case, Central Hudson or Niagara Mohawk or whatever. But it never really materialized. But basically, the concept is that, yes, when you send power up the coax to an antenna, you are generating a B field, a magnetic wave, an E field, an electrostatic wave. They're rectangular to each other, and pretty much the receiving antenna has to be in line with the magnetic waves to receive the information because it's of the similar receptor. It's not oriented. The conductors are not going to respond to electromagnetic fields. They're going to respond, or electro fields are going to respond to magnetic fields. Sorry about that. So that's why we have vertically and horizontally polarized antennas, and it's best to match them.
Now, Jerry mentioned the inverse square law, and especially in the demonstration I was talking about, we see close up that we can definitely transmit or receive power in close ranges. Somebody on this net has a wireless phone charger or has used one. You've heard me mention or joke around about the fact that I have one radio and antenna combination that I use in the house, don't anymore, but I have used, that turned my stove on several times. Has anybody ever gotten a fluorescent tube glowing from their ham radio equipment? There's all sorts of things like this. And when something's resonant, as Jim is talking, you get a different level of efficiency. What Jerry mentioned was inverse square law, which is the fact that the relationship of distance to the power of a signal received reduces as a product of square root, basically. So as you jump each measure of distance, you're not looking at a linear reduction in power, but a more accelerated reduction in power for each jump. So that means that, when you're far away from a transmitter, it's harder to hear it. We play with propagation, topic for another night again, probably, but, and that's why ham radio sometimes allows us to get halfway around the world with only 5 watts of power. But normally, there's many obstacles and things that cause those signals to dissipate. We need a little more sophistication to pull those signals out of the ether. But one thing, when I was listening to the late, great Dick Nadel, who used to run the Science and Technology Net on Long Island, one of the things he talked about is that even when you apply the inverse square law, the signal, no matter how impossible for you to detect it, is still there in some way or form, even though it may be at such a low level that you can't detect it. So, what about those louder signals? The practical first real awareness of what could be used, just powered by radio waves itself, was the crystal radio. And the theories for it came right at the beginning of the 20th century. And the practical uses came about 20 years later. It was discovered that there were certain metallic materials or oxidations of them. There are several different ways to produce this, but there were different crystals and metals that could rectify the received signal into something that could be turned into detectable audio. And early radio, which really was more for experimenters, didn't go commercial until it became practical for people to actually afford the receivers. The crystal radio became something you could make at home. And using crystal earphones or high impedance headphones, you could actually hear radio stations without electricity. Kind of cool. They still work today too. And a lot of us, maybe as kids or just getting involved in radio, built these things. You want to fish into your parts cabinet. The simplest radio you can build has a coil, a diode, and a crystal earphone. It's not tunable at that simple level, but with a strong enough radio station nearby, you'll hear something. And I remember making those as a kid. And at night, back when there was a lot of international shortwave, oh God, you'd hear 2 or 3 stations simultaneously fading in and out on top of one another if you played with the size of the coils. But add a variable capacitor to that, or a sliding piece of ferrite in the middle of the coil, and you can tune it. And we live in an area where there's some AM stations scattered around, and if you live in the proper range to one, or put up a long enough antenna on a crystal radio, you'll hear it in a quiet home through a crystal earphone, or hook it up to an amplifier, and it'll play. I mean, up in Kingston, you should be able to get 2 AM radio stations, possibly 3, on a crystal radio. Crystal radios aren't limited to medium wave AM. As I mentioned, I built shortwave crystal radios as a kid, but there is a way to make an aircraft AM VHF crystal radio. It was a project I saw as a kid, was a passive aircraft communications receiver. Why passive? Because, they were very, very, very strict about having any kind of radio turned on a plane. If you want to listen to the pilot talk, you could do it with a passive receiver. Chances of you being able to explain that correctly to the flight attendant, why you had a circuit board, a crystal earphone, and a wire taped to the window of the airplane, that's probably going to be hard to explain because most people aren't that technical. But it works, and there are people who used to make these things. Another interesting take on this W2NDG for ID. Another interesting take on this is the crystal FM radio. And I know a couple eyebrows went up when I said that. You can't, do FM detection with crystal radio. No, but you can do something called slope detection, which when you tune off of an FM signal slightly using AM detectors with the correct bandwidth, you can hear the FM signal. It works. And if you search in Google for crystal FM radio, you'll find a couple of projects that people have done for this, and they actually work. It's pretty cool. So these are all no power devices. And there's some people on eBay that sell high quality crystal radios, because you can make one that works a lot better than the other ones. There's a company called Borden Radio. The guy from Borden sells some really neat crystal radio kits. In fact, I think his website might be at crystalman.com. I'm not sure about that, but it's on my radio kit guide page. So Borden Radio. But anyway, that was one of the earlier, appearances of practical use for crystal radio, for getting RF energy out of the air. So that was one of the first ones I put on my list when I discussed this with Jim, and I'll let him expand on that a little bit, and then we'll go around real quick.
Thanks, Bill. Which brings back memories of my childhood. Dad, K2BHM senior. He built a mobile transmitter, 75 watts. Due to plug-in coils, would go anywhere from 80 meters up to 10. And he had a little converter that would take the receive signal and bring it down to 1 kilohertz for the AM radio. And he had a mobile rig. And so he was pumping out, about 75 watts, a 6-volt DC car system with a dyno motor. And he would pump out 75 watts into a Shakespeare big stick fiberglass antenna on the back. And while he was transmitting, you could take a 4-foot fluorescent bulb and come up to about 4 feet of the antenna and light the bulb up full brightness. And you could back away about 13, 14 feet, and it would still be lit. Not full brightness, but you would still see illumination in the bulb. So, there's a lot of energy out there, and interesting in the way it exhibits itself. So, I'll drop it back to Neil, K2BHM.
As I mentioned before, as a kid, there were a couple of people who really wanted me to get my ham license, and I didn't, but I had some equipment. And, as a, young, stupid kid, a friend of mine and I hooked up the transmitter the one day, and we're just playing around with it in the house. And we probably shouldn't have been doing this, but one of the things we noticed was that all of the under cabinet lighting in the workshop that my father had built on the back of the house would kind of, come on if we had the wire on the transmitter, the antenna wire inside the house. But yeah, you can definitely light things up, as we say. And if you've ever gotten an RF burn, there's energy there. Interestingly enough, that little tiny 5-watt radio I've been talking about a lot, into an improper antenna, gave me an RF burn on my finger the other day. Not a severe one. I mean, you're not going to get a whole lot out of 5 watts, but it was enough for me to go, oh, that's not right. So anyway, so the background, the theory, directivity, ambient energy, crystal radios. Let's go around real quick and see where we are. Let's put the original order back in place. Tom, N2FCC, any comments so far?
In the other room? N2FCC. No, it's interesting that there's all this power out in the air. It's like RFID. I think that powers itself through a transmitter. The receiver, that's how the receiver gets its energy to give its data back. But interesting stuff. N2FCC back to that.
Yes, and RFID is one of the things we're going to mention. There's different levels of it, but at the level I'm going to bring up, yes, you are correct. So, cool stuff. I'm curious as we go through. Tom, I'll just throw it back to you. Has anybody made a crystal radio recently? What about you, Tom?
NTFCC. Nope, I have not made a crystal radio recently, but I do remember when I was in college at Alfred, New York. We built a radio and went to the roof of the science center there, and we put up a dipole antenna. And this was during the day. We picked up the WNBC in New York City, so that was pretty cool.
And then we got, even though we were there with the teacher, we got yelled at for being on the roof. And to FCC back to that.
Anti-establishment, huh? Anyway, that's cool. Matt, KB2, GGF. Comments so far, and when was the last time you made a crystal radio?
Thanks, Neil. Let's see. For a comment on the subject of RF burns, what is the mechanism of that? I assume it's just that the RF energy is being absorbed in the water of the cells and it's being cooked. But is there some other mechanism of shock or burn that's going on there? That's something I don't quite understand and would like to. And so far as crystal radios are concerned, if you ever forget how to build one, just look at the American Radio Relay League logo. There you go, the schematic. Last time I made a crystal radio, I had a big box of germanium diodes of various sort and my trusty old crystal headphones and a ground and a coil, and I just sort of clipped it all together and yep, I'm getting a lot of RF signal. Can I tune it? And played with it for 10, 15 minutes, and then the crystal radio headphones felt like a lobster on my head, so I said, I'll play with this later. But that's the last time. I do have a Heathkit crystal radio, which was a crystal radio kit sold by Heathkit. And it's the model CR1 crystal receiver. And that's pretty neat. That is tunable. Anyhow, back to net, KB2 GGF.
All right, cool stuff. RF burns. And I'll have Jim verify, but I'm pretty sure you're right. It is pretty much just the RF energy, intense RF energy, focused at a point, exciting the molecules in your cells. Similar to what happens inside of a microwave, but going on with your finger, or in my case, with my old Atlas 210X, my lips. Not fun. Am I correct, Jim?
Yeah, pretty much. A microwave operates pretty much by, it is a 2.54 gigahertz transmitter, which excites the water molecule, which is resonant at 2.54 gigahertz. But basically, other than that, you impart some RF energy into something, and it's going to excite it no matter what the frequency is. It's going to impart some energy on it, which is going to raise its average kinetic energy and therefore temperature. So, yeah. It's basically pump power into it.
All right, thank you. And let's see. Your Heathkit kit. Those are collectibles now. That was a great crystal radio. 2 comments on that. There is a guy on eBay. I think it's called Pirate Pete. He sells kind of replicas of some of the Radio Shack P-Box kits, like reconstructions of them. He 3D prints the P-Box portion, and he has 2 different versions of the shortwave and the tube radio kit, but a few others too. But basically, a modern send-up of a couple of the P-Box kits. But he also has 2 different versions of a modernized version of that Heathkit crystal radio. One using, full metal tuning capacitors like the original one had, and a less expensive one that just uses the poly varicaps. And then NM0S, David Kripe, who designs kits for 4-state QRP, also sells some of his retired kits that, retired from 4-state QRP. David still offers them through his eBay store. and he had a very fancy crystal radio kit, which was similar to that Heath kit crystal radio. So, I mean, if you really want to play with this stuff, and like I said, this is a good area for it because we have a few AM stations around. As long as it's probably not right in your backyard, they're not super high power, and you should be able to get something. And at night, it's a lot of fun. I'll mention the last crystal radio. Well, no, because I've still built them. One in particular that I made when I was a kid was kind of interesting. I was getting static on my radios that was basically killing the ability to hear things. It was that bad. And I would hear it on the shortwave bands. I would hear it on AM, and sometimes, on a quiet passage in music or pause between words on an FM station, I would even hear it coming through on the FM a little bit. So what was it? I wanted to find out, but it was so strong, and I didn't have a portable radio that had an RF gain control at the time. I needed to seek it out. So I took a cardboard core from, I think, some string or twine that my mother had used up, and I wrapped some thin wire around it and twisted a diode on one end of the wire, and then put a crystal earphone between the other end of the coil and the other end of the diode. Stuck it in my ear, and sure enough, I heard the static. Now, it wasn't always there. It would come and go. And I started walking around the house with this thing. And I noticed that towards the back of my bedroom, it seemed to get the loudest, at least in my room. And as I walked around upstairs in the house, it was quieter. So, but there was nothing where the noise was coming from. There was nothing that could be causing it. So I went downstairs. And as I got to the bottom of the stairs, it got much louder. And I'm thinking, all right, so if it's right under the back of my bedroom where my desk and my dresser were, it must be directly under there, which ended up being the laundry room. And I traced the problem to the dryer. And what was happening is the timer, the spring had probably worn out a bit, and it wasn't turning off all the way. It was arcing. So at the end of the dryer cycle, for about half an hour to an hour, the thing would sit there just buzzing a little bit and creating this static that would just kill everything, because I guess it was a pretty powerful spark. But that crystal radio, that simple, non-tunable crystal radio, picked it up. And we ordered the part for the dryer, and I think I put it in. And that ended that. But what was happening was just vibration around the house, mom opening and closing the dryer door, would eventually work it to being fully off. But it would go hours at a time. And but it's neat. And if you have a really bad interference source around your house, you can do something similar to try to figure out where it is. So years later, I used the same kind of device to figure out that we had a bad transformer out on the street where my apartment was. So very useful. Lou, KD2 TVS, how are we doing so far?
Doing good. I'm listening here and reminiscing some of the aviation stuff that I used to deal with. And you guys were talking about AM and picking up the local stations. And it's one of the things I used to like to play with. I mean, on the older airplanes, 707s, 27s, I guess the original 757s, because they were built in 82. So they still came with something called ADF, Alpha Delta Fox, automatic direction finders. And basically, you just dialed in an AM station, and you look at your compass needle, it would swing and tell you which heading to go fly to head towards that particular radio station antenna. So I used to sit there in the middle of the night when I was on midnights, and if there was a late Yankee ball game or something on 770 AM or whatever, or I wanted to listen to the news, and I was working on something in the cockpit, I'd just turn on the ADF and set the AM radio and listen to something. It was better than listening to nothing. That's why you were sitting there. But it was was fun just playing with that portion of it. Watch the thing swing. I mean, the needle, the compass needle swing over to the pointing in a direction of 770. You always double check it going, yep, that's the antenna, that's where it's around that general area. It just reset. But I always saw the radios with me. I guess I was always more into receiving a radio signal than transmitting a radio signal. I mean, we use VHF for transmitting communications, talk to the tower anytime we were taxiing an airplane or moving an airplane or test an HF radio if, after we changed an HF coupler or something like that. But yeah, I mean, with receiving, because ILS, instrument landing systems, they dealt with picking up radio signals sent from the ground, so they give you the guide slope and your direction left and right to land the airplane. So, but you guys are making me reminisce a lot of stuff. But yeah, the conversation is very good. I'm learning about that, and I always wondered about that. Never really thought about that. Let me just reset again. About RF burns. I never really heard that until actually I started reading the manuals for the tech amateur license and stuff like that. And they would tell you beware of RF burns and antennas and HF and keeping the driven wires, I guess, away from where anybody could touch them while you were transmitting, I guess. And you would hear it like that. I never really thought that those things would really get hot or anything like that. But to a story, I remember years ago, I guess that must have been, 2021, I guess at the time, started to work for the airlines. And whether it was true or not, I cannot tell you. All I was being told was by one of the other guys that was working an engine adjacent to the one that I was working on, that there was a radio guy playing with the radar antennas and stuff. And so they had the radome up, and supposedly the guy who was working next to the engine over next to me said, "You should have seen that." And I said, "What?" He says, "The guy over there, the radio guy's working with the radar, I guess, or something under there. And apparently he had something in his back pocket that lit up. So I don't know if they had the radar on, because they usually had a kind of safety, it was kind of like a phone jack on a stream where you would plug in. So nobody, even if somebody inadvertently went upstairs and turned on radar while you were downstairs near the antenna, it would kind of like break the circuit where it wouldn't go on. But apparently maybe it wasn't in or whatever. Well, anyway, I didn't see it. So whether it was true that microwave antennas, from radar could light up bulbs, according to what I see online, I guess they can to a point. So let's hope he had babies or something. At least had kids after that or so. We're back to you, Neil. KD2 TVS.
W2NDG Friday. It's interesting that you brought up the radio direction finding. Technically, something like that could be done with the right kind of antenna, with a crystal radio. We've talked on here before, way back at the beginning of the net, I think. We talked about Ndvs, non-directional beacons, which is kind of what you're talking about. They still exist. There are some that are located in proximity to certain airports. There's one for the Orange County Airport on 335 kilohertz. I can get it from here. If you have a radio that tunes down that low, and most of our HF rigs do, Lou, you could probably get it. 335 kilohertz. If you tune there, you can zero beat it on sideband, but if you just tune it in on AM and try to filter out some of the noise, you'll hear a steady 2-letter Morse code ID. And that's what most of them are. They're 2, sometimes 3-letter IDs out there. And that's what they are. You would have an antenna where you would null the signal out. And when you nulled it out, the signal was exactly perpendicular to your antenna. And they would use those for navigating. So cool thing to bring up. And yeah, we've mentioned them before here. They're neat. All right. Jerry, comments, and what was the last crystal radio you made?
Yes, I was a very young child. I played with crystal radios. It was some commercial toy kind of deal. I remember a plastic case. I don't know, Rico or one of the companies made them. Crystal set, the whole deal. Very, very dim in memory now at this point in my life, but I remember salivating to get my hands on that. One year, my mother got that as a gift for one of my cousins, and it was all she could do to keep me away from it, from playing with it before she gifted it. I remember seeing mention various places of do-it-yourself crystal radios. The old Quaker oatmeal box, you wind the coil and all the rest of it. Sliding tap for tuning, dragging a conductor over the coil to do the tuning. And you mentioning, there's still AM radio stations around in this area that, you could play crystal radio with. And that brought to mind the thought whether or not you could do the same thing with the crystal radio set for the FM stations using smoke detection. I can't think of any reason it wouldn't work theoretically. Never tried it myself. Those of you out there that might be so inclined, maybe it's possible. And I had another thought here. Oh, yes, RF burns. Yeah, they could be really nasty. The worst burn or shock or whatever. Yeah, RF. Wow. Got a little hole in my hand playing with the aforementioned Tesla coil, a pair of 811As. I became an RF conductor, I am assuming, where the RF entered my hand and I became an antenna. Or at least that's my theory. Yeah, RF burns are the worst. WA2RKN, back to that.
Thanks, Jerry. And yeah, I was saying before, there's projects. If you simply Google FM crystal radio, you'll find a bunch of pages devoted to it. And that's exactly what it is. It's using slope detection. And some of them work quite well. There's a guy who was making them, once he got the theory of the design to work, he started making them, look nice. They were really cool. So if you poke around, you'll see not some of the results of that. And some of them are just downright art projects. But yeah, the RF burn, not something we want, but you play around with radios long enough and you're bound to get one. All right. We reached the end of the discussion group here of check-ins. Is there anybody else who wants to check in before Jim and I go on with the rest of this?
This is K2DED. Good evening, everybody.
This is KD2IWC, sandbagging, just listening and saying hello.
All right. And K2DED, I have you as Stephen in Hyde Park. Is that correct?
Roger. It's been a great discussion so far. Thank you.
You're welcome. Paul said he just wanted to listen, but do you want to add anything to the discussion?
Not at the moment, thank you.
That's fine. And K2DED, how about you?
Yeah, actually, you guys mentioned Tesla earlier when you were speaking about the electromagnetic field and stuff. I was actually just starting to get reacquainted with some of his history and life just a few days ago, and I was wondering if you would, or you or one of the other people would like to give their thoughts on. I was starting to question why did he seemed to stall. You know, he stalled after he got to that point of technology where he had this great idea and then it just stalled out, didn't turn into anything. And I just want to know if you guys have any theories on that. Not financial or anything like that. More of just what he was lacking in his theory, or why maybe it happened. Over.
All right. I may throw it to Jim for that because I'm thinking, and Jim can verify if he knows, that it might have to do with what Jim was talking about earlier, with that I think Tesla may have aimed too high. I think he was expecting to get more out of more energy out of radio waves than he expected. I don't think he was looking at it from the point of communications, but from power transmission. Jim, do you agree with that?
Yeah, KGBHM. Yeah, I don't really think he analyzed the inverse square law. I don't think he realized the losses that would be incurred in sending the energy through the airwaves without a solid conductor. Losses are bad enough as they are, sending AC over copper conductors, but sending it through thin air, the losses have got to be phenomenal. So I'm kind of guessing. I don't really I didn't research this, but I just off the top of my head think that it's the return on investments would be pitiful.
No, that's where I was going with it. And, basically, and you can correct me whether it's Steve or Steven, I think that it's something that we would have to research. We're kind of guessing, but it does make sense from what Jim was saying. If Tesla and looking at what he did in his theories, I think he was looking more at the ability to move power around wirelessly, whereas some of the other early experimenters looked at it and found other practical uses for it. I think when they realized that, they weren't going to be able to eliminate the overhead wires. Which I know at that point wasn't what he was looking at, but he was, basically looking to transmit electricity, and it ended up not being as practical, I think, as he thought it was. Back over to you, K2DED.
Yeah, Roger that. That's exactly what I was kind of thinking too, with just with the available information at the time, and everything was still so new that he maybe had jumped the gun on what he was expecting to get out of it. But it makes sense. I didn't know if you guys had had heard of any other reasons, but that's kind of what I figured too. But yeah, but it makes sense still to this day, All right, everybody, thank you very much. Back to Nick.
Thank you. And is it Steve or Steven?
This is Steven from Hyde Park, New York.
Excellent. Thanks for checking in, and you're welcome anytime here on the repeater. All right. Well, thanks for that. And we've gone through a few different subjects and devices. Let me just look at my notes here. And Jim, I wanted to talk about the Joe Tate project. I don't know if you looked into that at all, but it's certainly interesting. It's not a hugely practical thing, but it got patented, and it's definitely something that we as hams can experiment with. What do you think?
Is that the one from the Evil Genius where he is extrapolating power from the ether by just sticking up an antenna and diodes, capacitors.
Correct.
Yeah, okay. Where do you want to go from here?
Well, I wanted to talk about this because it actually surprised me that it was as recent an invention as it was. I would have thought that something like this came around earlier. So let me explain where this came from. I had a book on PDF, and I forget exactly where I acquired the PDF of this book, but it was something I think that was sent to me. And it's called 22 Radio and Receiver Projects for the Evil Genius. And it uses a number of, I think the reason why the book is not real popular anymore is that a lot of the projects in here were kits that were sold by the Ramsey Electronics Company, which doesn't make kits anymore. Unfortunately, it was a great loss to our hobby, but the schematics and parts lists are still in here. So even without Ramsey being around, you could still build some of these. And it's an interesting book to look at the theories, and the different projects are in here. But as I was paging through the book about a month ago or so, I came upon a chapter called the Ambient Power Receiver, and I had never heard of this. It makes sense, but I had never heard of it. So a guy named Joe Tate, T-A-T-E, in 1979, started experimenting with methods of extracting electrical energy out of radio waves. Now, okay, we have crystal radios. We know we can do inductive coupling. That's how, wireless cell charging works. But no, he wanted to know, how much power could I get out of ambient radio waves? Just what's in the air. And is there a way to maximize it? Is there a way to make it efficient? So he started playing around with this in 1979 and received a patent. He was granted a patent for this device called the Ambient Power Module, or APM. This is a properly arranged group of diodes and capacitors hooked up to an antenna to extract energy from the air as efficiently as possible. And there is there are several articles about it explaining the theory, how it works, and what you can actually do with it. So the project uses four 1N34 germanium diodes, very simple diode, and a couple of ceramic caps, a couple of electrolytic caps, kind of some short-term power storage and buffering, and an antenna. And this thing will draw enough voltage out of the air to power. I'll give you a couple of examples of what it can power. Those calculators that have the solar cells in them. If you disconnect the solar cell and hook this thing up to one of those calculators, it'll power it. Of course, it depends on the antenna and the amount of ambient radio waves in your area. But if anybody's ever seen the potato clock, it's a very low-powered digital clock that comes with a couple of dissimilar metal electrodes, and you can make the potato clock out of it. Works also with many other household vegetables and fruits you may have laying around. But that's a really low-power clock that could be powered by this as well. If you dig around, there's a couple of YouTube videos where people have charged up some storage cells with this thing, and it actually works. I imagine he was thinking of a more practical use for it if he had it patented, but it hasn't really going anywhere as far as, we're not going to run, a house on this. But there were some interesting things that came out of it, including the relationship between the energy levels and seismic activity, which is kind of neat. And there's some articles written on that as well. And you can build one of these. Like I said, it's a handful of cheap parts that a lot of us have laying around, and with the right kind of antenna, you could power an LED with it. Definitely. So definitely a cool design and worth looking into. Joe Tate Ambient Power Module, APM. Back over to Jim for any comments.
Yeah, definitely. He was looking at gravity power out of the air and setting it into a diode capacitor, detect the aim off of it, and set in a capacitor to generate a voltage level. And then it extrapolated to sending it into a voltage doubler circuit. You get twice the power, and then send another complementary over to the other side and get twice the negative power, and then send it to a doubler or a tripler or a quadrupler or whatever, and from there you could throw up 50 feet of wire and start to extrapolate some power off the radio waves going through the air. So, yep. It is logical, it makes sense, and it is doable.
Yeah, I'm thinking I'm going to build one. I've got enough copper in the air outside that I should be able to pull something interesting out of it. So I may throw one of these together. I think I have the diodes. If not, I could definitely use some. So I'll collect. But yeah, I thought that was really cool, and I had never heard of it, and I just was really impressed by that idea. Okay, Tom mentioned RFID, and that's something that some of us deal with all the time. And I know one example I'm going to use is my ID badge for work. I work at Sloan Kettering in the city. We have a pretty secure building. And I wear this badge around my neck that has a picture of me and, my employee number and who I am and my title, my department. But to get into the building, I tap it on a little plate and the gate opens. To get into my office, because our office is a secure area, I tap it on a plate on the wall and it unlocks the door and lets me in. If I'm attending a seminar in one of the conference rooms downstairs and I need to get credit for it, I tap the plate on the wall on my way into the room, and it beeps and it registers me as having attended that meeting. There's a number of things that they use it for. Oh, when I get my flu vaccine at work every year, they have a little tap plate on the vaccine card that I tap that identifies me to the nurses giving the injection, and automatically fills my employee information into their computer. So this thing that hangs around my neck is an RFID tag. Sandwiched in layers of plastic in this thing are some devices. Well, what's in there? W2NDG on the OMARC Sunday night Science and Technology Net. RFID is composed of an antenna, a very simple receiving circuit, and a tiny chip. And the chip is a very small microprocessor and communications chip. And basically, what this thing does is it receives a signal saying, wake up, and it barks back a number in binary code, whatever it is. I can't really get to the nitty gritty because I don't know exactly what it's transmitting, but it is sending a radio signal out, which is a number which registers in some computer system as whatever that card is. In my case, it says this is employee quadruple 068088, and the computer identifies that number as me. So, but how does that work? There's no power in the thing, but it's RF powered. Now, there are 3 levels of RFID products. There are completely active ones. There's hybrid RFID, and passive RFID. These are passive devices. They work at a very close range, and usually any of these tap and go type of things are close range RFID. Your tap and pay credit cards, for example, are passive RFID. Hybrid is something like your EasyPass tag. Your EasyPass tag has a battery booster in it that's basically allowing it to work at a faster speed and a further distance. It makes those batteries last quite a while too. I don't know if anybody's ever had one die, but it takes quite a while. But yeah, so 80 miles an hour on the thruway, those tags are good 20, 25 feet overhead, the readers, and it's still picking you up. So that's the hybrid ones. What's an active one? Your cell phone. There's a good example. So the passive ones use an antenna, and if you've ever taken apart one of these things, you'll notice there's a coiled up antenna made of very, very thin, flat copper foil. And what makes this thing work so well is that is a tuned antenna. If you were to unravel it and really examine it, you'll find a tiny tuned dipole in there, all, of course, coiled up and folded up, but it's tuned to the operating frequency that the RFID system is using. And as Jim was talking before about resonant antennas, you get a level of efficiency that is transferring enough energy into that card that's hanging around your neck, in my case, to power this chip. And that chip powers up and says, I have electricity. I am, and then it sends a hash number out through its antenna. So it transmits after it receives. And then the wall plate gets that number. If that number is the proper length, and there's probably however many bit error check number at the end of the string, and if that checks out, the wall plate beeps. The computer says this number is allowed to open this door, and my office door goes click, and I can go in. But that is an entirely passive operation, and by making that antenna as efficient as possible, they can get enough electricity into that chip to do this. Kind of cool. What do you think, Jim?
Yeah, definitely. Jim here. The technology has really expanded because of the low current capabilities of the FETs and so forth over bipolars. Bipolar technology, 222s, whatever, they needed milliamps. When you got into FETs and so forth, they needed microamps and now nanoamps. And so it's to the point of where just sniffing a little bit of current off of the transmit signal is enough to bring up the computer and elicit a response. And you're basically in the door.
Yeah, the first time I heard about it, I thought it was really cool. I know a girl I used to work with at AOL who was one of the developers in the media group. And I think she broke I think the way this started was maybe she broke one of her RFID tag cards at work or something and found out what was inside of it. But she became fascinated with how this stuff worked. And her boss got in touch with me one day and said, Amelia wants to know about radios. And I know you're a radio guy. Can you, talk to her about radio? And this is basically what she was asking. How can something work without electricity? So I, told her about crystal radios and suggested she build one. And of course, in New York City, there's plenty to listen to on crystal radio. And she started experimenting with her own RFID readers. And incredibly bright girl. She built her own RFID system and was playing with that. And she went on to start working with mesh networks and all sorts of things. And now I'm pretty sure she's still doing this. I think she teaches and lectures at NYU on such subjects and other things. But that's what got her into it, was just, how can this thing hanging around my neck trigger something without actually connecting to it? Definitely cool. Let me drop. So I had one more component to this that I put on my list, and this is a very recent thing that's come up. And if you really want to know how far this has come, and here's a question after I talk about this device. I wonder if they paid any royalties to Joe Tate, if his patent is still active. Samsung now, I don't know which devices they're offering this with, but Samsung has a remote control for some of their devices that is powered by Wi-Fi. I think it also has a solar cell on it, but it can charge just based on your Wi-Fi signal and will get enough power to charge itself up and continue to work. So a batteryless remote control for some Samsung devices, and it is Wi-Fi powered. How cool is that? What do you think, Jim?
Yeah, I saw that. Very interesting. They're sniffing these slice amount of power off because they are such a low power application that it works. Interesting. But I don't want to really know what other kind of doors that opens.
Oh, yeah. Well, we've been sitting here talking about RF energy and what it can power, but, there are other ways to generate electricity, other things that can produce electricity or other forms of measurable radiation. And when I say radiation, I mean non-ionizing radiation. For example, kinetic energy generation. And I'm not talking about generators because that's more of an electromagnetic thing. I'm talking about being able to turn vibration or pressure into electricity, piezoelectric electricity generation, and kinetic, getting electricity out of sound, which is how a basic, crystal microphone works. It's creating electrical signals from kinetic energy from sound waves. There are ways, for concussion, basically, or percussion, sudden shocks, sudden jolts, or pressure sensors, small devices that can generate electricity based on physics, on kinetic output. So there's one for you. Heat. And we've talked about thermocouples on here before. What is a thermocouple? A thermocouple is a device that takes the difference between something that's really hot and something that's really cold and creates energy out of that difference. And it has practical uses in everyday life. W2NDG on the OMARC Sunday Night Science and Technology Net. The term thermocouple, we frequently hear it when we talk about home heating systems, especially ones that use gas, either propane or natural gas, and a thermocouple. A lot of people think of it as a mechanical device, but it's electrical. And basically, there's a little piece of it that's in the flame of a pilot, usually a pilot light, and the other end of it is not. So there's your temperature differential. And while the piece that's in the flame is hot, it produces a very small amount of electricity that keeps the gas flowing in the pilot light. If the pilot light goes out, that little piece that's hot in the flame cools off, and suddenly there's no temperature differential anymore. And with no electricity, the valve closes, and there's no longer any gas going to where the pilot light was, and you won't have an explosion because you've been trickling gas into a room for days and days and days and days, not realizing it because you were on vacation. Anyway, but that's when we hear the word thermocouple, that's the first thing that comes to mind for a lot of people. But you can generate electricity with a thermocouple. There was a project many years ago when I was a kid that my brother got in a magazine. It might have been Popular Science, Popular Mechanics. I don't know. I can't remember. But it was a radio, one step above a crystal radio. It used a couple of transistors and some other pieces to be able to pick up stations a lot better and amplify them a little bit. And it used a thermocouple to generate a little bit of electricity to make it work. And basically, it was like you would build it into like an old coffee can or food can, and you'd put the thing on top of a candle, light the candle, and it would power the radio. It was enough heat. So, and the other little experiment that I mentioned on here before has to do with Peltier Coolers, which are those solid state coolers that are in those little tiny 12-volt picnic coolers that you see for sale, and some of them are more efficient than others. Or Peltier cooling in electronic devices is basically a bimetallic device, solid state, that when you apply electricity to it, one side of it gets hot, the other side of it gets cold. Little tiny heat pump. But just like with the motor being able to use as a generator, the device can work in reverse. How do I know? I have an old one that must not protect against the backflow. And I had loaded up the cooler with ice because I knew I wasn't going to have electricity, but I still had this cooler. So I put a lot of ice in it and some ice packs and closed it up, and it was a really hot day. So I suddenly had temperature differential. I had cold air inside of the cooler and really hot air outside of the cooler. And I heard it running. And what I mean running is that there's a fan in these things. It circulates air over the device to make it work more efficiently, and circulates a little air inside of the thing. And the fan is powered, by the electricity coming in to the Peltier device. But I didn't have it plugged in, and the fan was spinning. I could hear it spinning. It was generating electricity because of the difference between the inside of it and the outside of it. So electricity comes from many different things. And if we can make any number of them more efficient, we might use them. But none of these are efficient ways of generating electricity. But as the technology of the devices gets better, we don't need as much power to run them. So 12-volt devices, okay. There's certainly a lot of 12-volt devices in ham radio. 5-volt devices. Holding a radio up to the YouTube crowd here. This is a rechargeable, portable AM/FM radio. Uses a lithium-ion battery, and it charges with 5 volts. Okay, so lots of 5-volt devices. Your cell phone, even though the speed charge ones, technically you could say they're running 12 volts. No. Cell phone is a 5-volt charging device. And depending on lithium-ion batteries and these things, this radio I held up has a 3.7-volt battery. Some of our phones are 7.4 volts. All right. Where am I going with this? Here's another one I'm holding up. And this is not a new device. This is a little Sony headphone radio. They made these years ago, the SRF 59. Now, radio is kind of legendary in some of the DXing lore. There's a group called the Ultralight DX Group. You'll find them on Groups.io. And they use small radios to do broadcast band DXing. This is one of their favorites, the Sony SRF 59. Why am I bringing it up? It runs on one triple ASL. Pretty cool. So, yes, I can definitely see Samsung being able to engineer a remote controller can run on Wi-Fi waves. Neat. All right. Jim, anything you want to add towards the end here, and then we'll go around one last time with our check-ins.
Yeah. Yeah, with the advent of modern electronics, silicon, you needed about a half a volt loss to the transistors would have a 0.5 volt loss between base and collector and so forth. Yeah, so it was not really efficient. Germanium was a lot better and so forth, and now they're coming into new technology that will respond to a lot less voltage. You don't really need to have a higher voltage threshold to activate the device. So, stuff is working now off of 3 volts or 1.3 volts or something like that. A lot more efficient. Definitely. And as far as the Peltier effect modules are concerned, did a lot of work with them. They are definitely a good methodology for applying power to something. And now that the voltage levels are much lower to accomplish something, they're becoming a lot more effective. It is quite a different world from what I played around with years ago and what you did as well. So, back to you, KGBHM.
It is. And I guess what I was getting at before is that, if some of these other sources of energy haven't produced by the standards of Joe Tate in the 70s or Nikola Tesla, didn't produce as much energy as they wanted them to make them practical at the time. Maybe the devices are evolving to allow us to use these sources of energy going forward. So that's kind of that don't raise the bridge, lower the river type of mentality, I guess. But that's what we're looking at. So, yeah, I've heard of things about, like sneakers that can charge a battery. I've heard of clothing that can produce enough electricity to, charge something. There's definitely a lot of things that will be looked at like that. Recovering energy. There's certainly a lot of places where energy gets lost and wasted, and we don't think about it. But, obviously the car companies did, and that's what hybrid cars are. Getting energy from your braking system. Instead of just turning it into heat and sparks and brake dust, why not take that energy it takes to slow a car down and put it back into something? I think we're going to see a lot more of that. And I think it's really cool that we're seeing the first practical commercial use of that. Who knows what's next? So as devices become more efficient and the methods of extraction become better, we might see more RF-powered devices in the future. Anyway, let's go back around one more time and see what everybody thinks. We'll call this the final round and send everybody off with something to think about. So, Tom, N2FCC, are you still with us? What do you think so far? Well, comments at the end here, I guess, is where we are.
N2FCC. I've been listening on and off. Had to go walk the dogs. Interesting stuff. And as you were just saying, with the increase in efficiency of devices, it's more practical to recover energy. And if you have a thermocoupled sweater, you could be harvesting making use of the heat of your body and stuff like that. So very, very interesting. And like you said, maybe it wasn't practical for Tesla, but it could be practical for devices now. So interesting stuff. N2FCC, back to that.
Yeah, and I have to tell you, I really didn't think we were at a point where something like that would pop up. But when I first read about that device, I was just a big smile on my face, just like when we saw software-defined radio starting to show up in everyday household products, things like that. So it's nice to see that technology end up for practical use. Well, thanks for coming tonight, Tom, and we will catch you next Sunday. Matt, KB2GGF. What do you think of all of this?
Interesting stuff. And when you were talking about the piezoelectric effect, I immediately thought of the piezoelectric acoustic pickups that they have in guitar saddles or ukulele saddles, any sort of stringed instrument you could put them in. So while you're practicing, you can be charging batteries. But it is making some electricity because it can then be sent to an amplifier and give you sound. So pretty cool stuff. Yes, as you were saying, lower the river, don't raise the bridge. Perhaps so, but 10 years from now, I think it's going to be a vastly different world, technologically speaking. Things are changing very rapidly, so stay tuned and definitely avoid the RF burns. Back to net, KB2 GGF.
Yes, especially on your lips, right where we don't want to have RF burns. Thanks, Matt. Talk to you soon. Lou, KD2TVS, parting thoughts.
Thank you, Neil. Boy, did you give me a lot of stuff to think about tonight. And the more you continued on, the more Thomas Kick pops into my head. Let me just reset. Okay, we'll go back to the first thing, I guess, from the previous conversation, the Ndvs. And yeah, familiar with those. And the VORs, every time you dial them in, they send back that little Morse code to you, so you know you're dialed into the right station by giving you the Morse code identifier. So yeah, I am familiar with those. And let me see. The other ones you brought up was piezoelectrics and thermocouples. Very familiar with those on airplanes. Thermocouples we use to measure exhaust gas temperature on turbine engines, and I guess even on the old reciprocating engines, they have them too. I guess somewhat. They usually with the jet engines, they'll stick a number of them in the exhaust pad, I guess, and they're out onto the case, and they use some kind of bridge circuit to kind of average them out. So on startup or anything, you don't cook the engine per se. So they can pilots can watch their exhaust gas temperature and make sure that everything's performing okay with the engine. So that's one for thermocouples on jet engines. And piezoelectrics, boy, that brought back some memories about fuel systems on some airplanes. in the fuel system, when you're fueling an airplane, towards the wingtips, they have what they call a surge tank. And the surge tank is basically just in case, since the tanks are vented while you're fueling, and normally, if you fuel the airplane a little too improperly or too fast, you may fill up those vent tubes with fuel. And the system is made so if they do catch fuel, then they're ported out to these surge tanks on the wingtips temporarily until I guess they eventually gravity flow because of the angle of the wing going from wingtip to the fuselage, and they'll drain inboard again and kind of normalize. But if it's done a little too fast, and let me just reset. They had a Siemens system. I remember they had piezoelectric sensors, or actually, I guess they're not really sensors. They're electrical generating units. And if that tank would, or fuel was splashing in there, the noise would generate, I guess, it would pick up, the piezoelectric would pick up the sound generation and generate a current and cause the fuel system, or you to stop, the fuel system to stop taking on fuel. And so you wouldn't spill the airplane, because the airplane has vents on the wingtips. So you don't want to spill it and have jet fuel coming out of your wingtips while you're fueling the airplane on the gate. So it was a safety factor. So that's why I remember piezoelectrics from that we were familiar with on them. But yeah, you brought a lot of information onto the whole thing. And let me just reset for the last one. Yeah, we were talking about, I guess, Tesla and all that theory of he wanted to transmit electricity through the air and put it in another place. But I can't remember where I read it, and it was recently, and it may have been an article about Tesla and something with modern day. And they were talking about actually taking and focusing microwaves to a distant receiving antenna, and thereby, I guess, at that point, somehow it's converted into electricity, and they use it. They store it in batteries or whatever. And I can't for the life of me remember where it was that I read that, and it was recent. It was maybe about less than a month ago. So I guess I'll just have to look that up, see if I find it again. But anyways, it's been a great night tonight. A lot of things were discussed. A lot of things emerged from the discussion that we had, I guess. And it was a great one, great night. So thank you, Neil. And thanks everybody who participated tonight. And have a great week until next Sunday night. So back to you, Neil, KD2 TVS.
Thanks, Lou. Appreciate it. And yeah, they've talked about ways, to actually, I think, realize Tesla's original vision and transmit power. And it does have to be very tight and focused. And we probably aren't talking about, something up in the microwave ranges. The issues become, I think, safety. God forbid something got in the way of that transmission, like an airplane or a spaceship. Or, I mean, that's when we talk about transmitting power from point A to point B, or being able to do it. That's one of the things that you'll hear is, powering something that's in orbit, powering something that's far away or in a place where it can't get power in any other way. But yeah, I think there's a safety factor there. That's one of the things that they talk about. It's, it still may come in our lifetime. We'll see. But thanks for being here, and we'll catch you next week. Jerry, WA2RKN, parting thoughts, parting shots.
WA2RKN Friday. Yes, I am going to step on the rudder pedal and change direction. See what I did here, Lou? Yes. Before I do that, trying to sell it to J.P. Morgan, who was bankrolling him by pushing the communications aspect, because after all, you could charge for sending messages. We're all familiar with the Western Union now. But he was intending to transfer power. The sticking point, however, is who was paying to generate the power. He didn't want J.P. Morgan to figure that piece out. Anyway, we're done with that. Now, pressing the rudder pedal, Dr. Professor Oleg Jeffimenko. Have you heard this name? Corona motor, electrostatic motors, powered by atmospheric electricity. There is a voltage differential between your head and your feet if you go and stand outside. I don't remember the exact figure nowadays. I mean, this is many decades ago. I'm thinking it was something like 100 volts per meter or thereabouts, but don't quote me. There was an article in Scientific American in the amateur scientist column that you could build the device yourself. And nowadays, lo and behold, we have search engines and the internet, and certainly enough, there are references out there to Dr. Professor Oleg Jeffimenko and his Corona discharge motors. Worth a look. That's part of the energy stuff that wasn't touched on this evening, but I'll throw my 2 cents in. May you all enjoy going down the rabbit hole. WA2 RKN, back to net.
Barry, thanks for that. This is fascinating. Yeah, there is a Wikipedia entry for anybody looking into this, and plenty of other things that came up when I Googled it, but there's a Wikipedia entry for the electrostatic motor. Electrostatic motor or capacitor motor, and then it talks about the name Corona motor that Jerry used. Interesting. And if we've heard about them creating, microscopic little engine or motor, I believe this is the method or the theory they used to create it. It was one of these electrostatic motors made of nanotubes, carbon nanotubes. I did hear about that a while back. Apparently, that's how they got it to work. Interesting stuff, Jerry. Thank you. Very cool. So, definitely something to read more about. Okay, we had 2 other people who checked in at the end there. Stephen from Hyde Park. If you have any final thoughts or parting comments, you can come now.
This is K2DD. Yeah, I just wanted to thank everybody. This is super interesting. We went over a lot of stuff, and I love it. I couldn't get more. You guys could go on for hours and hours. I would sit here and listen. So I really appreciate all you guys giving such a good net tonight. I did look up that PDF / book about the 22 radio receiver projects for the Evil Genius, and looked up the Ambient power receiver. It looks pretty interesting. I definitely think you should do a little experimental trying to build one yourself. But as soon as you were explaining it, I would just immediately popped into my head to say about staging it up to making, like, instead of just using one wire antenna, making like a sail of multiple hundreds of these wire antennas and seeing how much voltage you can get out of something like that. I would love to know what you think. Maybe another net. Everybody have a great night. Thanks a lot again. K2D.
It's interesting because the thing that popped into my head now was the idea of sailing to the stars. There is a way to move spacecrafts with large sails. It's definitely something that's come up in science fiction multiple times, but it's a real theory. And with something large enough, you're using a sort of cosmic pressure to move things. You could also, because the radio waves don't stay on our planet, they escape And there's plenty of electromagnetic radiation out in space too. You could probably harvest some energy to run devices out of the same thing. I think we're probably hundreds and hundreds of years away from something like that, but it still is a cool thing to think about. Paul, I don't know if you're commenting or not, but I wonder if we stretched a wire from my house to your house and used this device, I wonder how much power we could generate.
I don't know. I mean, whatever power is being delivered from the radio.
I mean, what's the distance between our houses would be a full wave on what frequency? It was an interesting thought. How long can you make an antenna? There's another question. That would be great. And we'll have Jim answer this one if he was thinking about it. What's the longest antenna in the world? Paul, thanks for coming. Anything else you want to add before we close up?
No, I've been listening on and off, pretty much enjoying hearing you go through all of this. And if we're about a mile apart, I imagine it's just a matter of calculating the frequency. And I'm guessing it's going to be low. And from what I understand, the militaries have some super low frequency stuff to talk to the submarines.
Yes, they do. And Jim has talked about LORAD on here before. So a navigational powered system using that antenna. Paul, thanks for coming by tonight. And good to meet you in person today as well. That was cool. Do we have any last minute check-ins before we close things up?
Comment, WA2 Hurricane. K2SQO, just saying hi.
Comments, KB2GGF.
Copy, KD2TVS.
All the comments. Let me just, before we hit the comments, let me throw it to Jim for comment. And he might have liked my question. What's the longest antenna in the world? I don't know the answer.
Thanks, Neil. I don't know the answer either, but they got some pretty impressive dishes looking for extraterrestrial communications. I don't know. Does that correlate into the equation?
I know there's formulas. I mean, a large, dish antenna has an electrical length when we talk about antennas, but I don't know how that correlates to all of this. It's just interesting, though, that somebody out there who has a huge piece of land has like a 3 mile long beverage antenna or something like that.
Yeah, but how does a 3 foot long beverage antenna or 3 mile long beverage antenna correlate to an array of 75 100-foot dishes?
W2NDG for ID. Well, that's where it gets beyond me, and we'd have to have a radio physicist on here to explain how so is it a function of the distance between the antennas, all sorts of things. I wouldn't mind knowing that, but yeah, definitely a good question. I don't know why it popped into my head, but anything else, and then I'll take comments, the 3 comments that popped up.
Quick comment?
Yes.
Yeah, I think it kind of correlates to the aggregate overall gain of the antennas versus what would
a 3-mile wire.
And two completely different things. That 3-mile wire is probably going to do really well on our, what is it, the 2200 meter band, for picking up, intercepting the communication to the subs at sea. The satellites are looking at much higher frequencies, I believe, but not always. I mean, you can definitely find things that are receiving higher frequencies than radio telescope stuff. But yes, I think you're talking more about gain and focus when you're dealing with that many dishes. I was just wondering, like, the longest wire antenna in the world. It's a great question. I don't know if it's possible to look that up. So, anyway. All right. Jerry, you had a comment. You were first up with the comment.
First, a little bit of clarification about the atmospheric voltage. Yeah, maybe about 100 volts per meter or whatever, but the higher up you go, the higher the voltage gets between there and ground. That being said, you may want also to look into Lord Kelvin's thunderstorm, or how you make sparks out of water. Lou may be familiar with this. Dropping water from drops of water from an isolated, insulated conductor, like a water tank. You can develop a charge because the droplets are taking some of the charge away and leaving you with a charged body. Lord Kelvin's thunderstorm. WA2RKN, back to that.
Well, something else to look up. And I'm doing it as we speak. Interesting. Yeah, autocomplete. I got as far as Lord Kelv, and it Google knows what I'm asking. All right, I'm gonna look into that one next. I did. I was poking around at this question of mine, and apparently the project Sanguine, which wasn't completed, Project Seafarer, which wasn't completely done, Project ELF became operational in 1989, consists of 2 transmitters, one near Clam Lake in northern Wisconsin, the other at Republic in Michigan's Upper Peninsula. The Michigan and Wisconsin sites, separated by 145 miles, must operate simultaneously. The Wisconsin antenna consists of 2 lines, each 14 miles long. The Michigan antenna uses 3 lines, 2 about 14 miles long and 1 roughly 28 miles long. And apparently the submarines that are using or were using this system, I don't know if it's still active, it looks like an old article, were using trailing wire antennas that they dragged behind them. Cool. Matt, your comment.
Well, that's interesting because my wise guy comment about the longest antenna, that's simple. A spare pair and a landline back to the CO. But those 14 and 28 mile antennas are probably set up much like telephone cable. Long runs of poles, I'm sure. And my other comment is if you were to stretch a guitar string between you and Paul and made it a mile long, you could do that with nylon or fluorocarbon and set up an array of piezoelectric pickups. You could generate quite a bit of power, I imagine. And that's my big twang theory. Back to net, KB2, GGF.
You'd have to pull it taut enough to get it to vibrate at a audible frequency. But interesting. I'd love to see that antenna. I have to find out if it's still in existence. Thanks, Matt. Thanks for coming by. Lou, your comment.
Okay, Neil, mine was more of a question. you mentioned about that little evil thing there with the PDF file that Steve was talking about, and I forgot to write that down. Just refresh my memory. I guess I could probably look it up online and see what it's all about. Back to you, Neil. KD2 TV.
All right, thanks, Lou. And before we close up, were there any last minute check-ins?
Yes, there are.
Oh boy. You're going on vacation to Wisconsin to view the world's longest antenna, right?
I'll have to put that on the list. Not this week.
And that sounds like Bob, K2LD. Thanks for checking in, Bob. Now, we could probably string an antenna from where Bob is to here. He's got enough height that we could probably do it without hitting anything. All right. I don't know how long you've been listening, Bob. If you have any comments before we close things up, but we're about to wrap it up for the night.
Well, I was listening to you on my drive home. It was, not 100% clear all the way, but now that I am home, I can actually hear the rest of it. But it sounded like a real interesting discussion tonight. Sorry I didn't hear the whole thing. But thank you for having the net, and thanks for having me aboard.
You're welcome. And the 15-minute synopsis of what brought this up was in a project I found in a book for creating an electricity harvesting device that harvests enough electricity out of ambient radio waves to power something. And the same week that I read about that, Samsung had announced an announcement that they released a Wi-Fi powered remote control. So I thought it was interesting that those two things came to me in the same week, and that's what made me think of this. Anyway, let's wrap it all up. Jim, the last word.
Thanks, Neil. Yeah, very interesting tonight, and glad to hear from you, Bob. Missed you. I missed the last couple of nets. I slept through the one the other day, and this morning was preempted by the bike race in Woodstock. So basically missed it. But I'm back on the seat again, and I'm happy to report that my back is doing much better. Not where it should be, but doing a whole lot better. So anyhow, thanks everybody, and back to you, Neil. That was my update, K2BHM.
Thanks, Jim. Of course, the repeater has to have the last word, I guess. Well, thanks for being here with me tonight for this. I enjoyed this one. And thanks, everybody, for checking in, coming by, and contributing. Let's close it up. You have been listening and or watching the Overlook Mountain Amateur Radio Club Sunday Night Science and Technology Net with Neil W2NDG and Jim K2BHM. We meet here every Sunday night at 8 p.m. to discuss science and technology, not always ham radio related. And you are welcome to attend either through the repeater or on YouTube. And the YouTube videos remain archived. You can check them later on. Please join us on this repeater for the other nets that take place here. And once again, you don't have to be a member of the Overlook Mountain Amateur Radio Club to participate in any of our nets or use the repeater, but we do invite you to join. Real fun club, very friendly, and lots of activities. You can find us at omarcclub.org, omarcclub.org. There are 2 daily nets held on this repeater, one at 8:35 a.m. and one at 6:30 p.m. The 8:35 a.m. net is a casual roundtable net, not a directed net, held every morning at 8:35, started at the beginning of the pandemic to keep people in touch and make sure that everybody was okay. The 6:30 net is the 6:30 check-in net, also a casual net, but a casual directed net, run by a rotating cast of OMARC characters. 6:30 net is usually 2 rounds, completes in half an hour or a little over, and just everybody checking in to tell us what they did and what they're doing tomorrow and whether or not they have any questions or need any assistance. There are 3 weekly nets on the repeater. Monday nights is Undernet, the Ulster Northern Duchess Readiness Net. A group of hams discussing being ready in the event of an emergency, how to be prepared, and what types of technology and how to use them that we would deploy in the event of an emergency. What's interesting is they get into all sorts of technologies that aren't usually discussed by a lot of the emergency organizations, and it can be a lot of fun. They like to send files and pictures back and forth over FM radio, so and have little activities on video channel before the net and on weekends also in parks and such with little demonstrations. Please join us for the Ulster Northern Duchess Readiness Net on Mondays at 8. Every Thursday at 8 p.m., Dave, K2JLV, hosts the Thursday Night Technical Net, a more ham radio-oriented tech net. Dave takes check-ins, sometimes suggests a topic, but asks for topics from the check-ins. And sometimes people have a troubleshooting problem or a technical question that can launch a topic for us. If not, Dave comes up with one, and that net can usually run 4-5 rounds into the night. It's a lot of fun and has solved some interesting troubleshooting and technical issues. So please join us on Thursdays at 8 for our technical net. The third net, of course, is this one, Sundays at 8 p.m. Off the repeater, we now have on Wednesdays, we sponsor the Wednesday HF net, the Hudson Valley 80-meter HF net on 3835 kilohertz at 5 p.m. on Wednesdays. So please join us for that as well. You have been listening to and or watching the Overlook Mountain Amateur Radio Club Sunday Night Science and Technology Net. I am Neil, W2NDG, broadcasting live from Highland, New York. And we are closing the net. I'm going to end the YouTube stream right now. Everybody have a great night. I'll hang out for 5 or 10 minutes, but I think I am ready to turn it in. Everybody have a great night. 7-3. Catch you next week.